Uh, uh, Good afternoon, everyone. It's my pleasure to introduce Vijay Krishnan. He is CTO and co-founder of Turing.com. Let me talk a bit about Turing before I return to telling you more about Vijay. Turing enables foundation model companies like OpenAI, Anthropic, Google, NVIDIA, Meta, Microsoft, and many others to improve their capabilities in areas such as reasoning, coding, function calling, multimodality, factuality, safety, and more through expert human data for evaluations, supervised fine-tuning, RLHF, etc. Turing also helps large enterprises like Pepsi, Disney, and J&J to strategize and execute various AI solutions to create outsized business value. Turing achieves both of these through its talent pool of over 3 million software developers, data scientists, and other knowledge workers spanning over 100 countries, all automatically vetted through their extensive tests of skills and expertise. Founded in 2018, Turing became a unicorn in 2021. Vijay obtained degrees in computer science, including a bachelor's from IIT Bombay and a master's from Stanford University. He has over 20 years of experience across academia and industry, where he has spearheaded large-scale machine learning projects addressing a wide range of industry challenges. I will just conclude my introduction with two fun facts. First is I learned recently that they were the providers of data to OpenAI as far back as 2018, well before they became a household name. And more recently, if you're wondering why all these LLMs have the same kind of persona and reasoning abilities, I think you can blame Turing. That I will hand it over to Vijay.
Thank you, Mayur. Can all of you hear me? Wait, do we have a clicker or we don't? Oh, this one. Okay. Yeah. Sorry, I have to point it somewhere specific. Oh, sorry. Oh, it is off. Oh, no, it is on. Sorry, how do I use the clicker? That's okay. I'm okay to manually tap this. All right. All right. Hello, everybody. Thank you for this thing, for your interest in this topic. I certainly hope to share a lot with you on this topic. Hope to get your insightful questions. Please feel free to interrupt me anytime during today's talk. I've set up this so that I have maybe I want to say 25, 30 minutes worth of content, but I hope to mostly have a bunch of engaging discussions either in line or after the talk. So first, maybe let me lay the groundwork, right, for human data and improvement to foundation models. So today, first, just like a show of hands, like I mean, Colum attendees, of course, are very likely to be steeped in LLMs. But I'm curious among all of you, like how many of you have done some work on LLMs, some research on it, want to do research in it, etc. Great, great. Okay, that's great. Yeah, I hope a lot of this will interest you. So specifically, the angle yeah. So today there are some levers for model improvements that are quite well understood, right? We all know that more compute is helpful. The scaling laws have been holding. There's a reason, there are all these discussions around global GPU shortages. There's even discussions around building new gigawatt or even terawatt power plants and all sorts of things for the purpose of feeding the infra portion of this. And when that is, of course, well understood, and all the big players have this in large volumes. Consequently, it becomes more like table stakes. It doesn't quite generate necessarily competitive advantages. When it comes to algorithms, again, work has shown that a lot of differences in algorithms don't necessarily lead to better quality predictions by LLMs, but often many of them lead to efficiency improvements and so on. So, and at any rate, a lot of methods, including the ones, the self-play methods used in O1, etc., again, are very much used by all players. And this too often becomes more like table stakes rather than a competitive advantage. Of course, everyone knows there's a certain amount of play with common crawl kind of data, with cleaning that data, using the right subsets of the data and things like that. And this play again ends up being fairly fairly common across a lot of companies. So then that leaves the fourth point, which is a high impact lever, but I think it's less researched and also less understood. And fundamentally, this leads to a lot of competitive advantage. Part of the thing that I think leaves this area a little bit untapped also is that this ends up, this specific lever ends up being somewhat messy and somewhat empirical in nature, and sometimes not perfectly, suiting the kind of elegant solutions that you might want as researchers, basically. So specifically, the key insight here is that human data for post-training in certain complex domains can be very valuable. And what makes the ROI of this quite attractive is the fact that one can often measure early improvements with as little as 1,000 to 5,000 SFT examples. So if you had a high-skilled worker that took an hour or two to complete a task, and if the model was able to learn in as little as this and was able to get very good for with a few tens of thousands of examples, that can make this economically very, very viable. And yeah, needless to say, that is what Turing plays in. And I'll give you a bit of a background about Turing itself, and why we are playing in this space, and so on, and then mostly go into some of the best practices around use of human data itself. So first, why are we in this space? Well, we have one of the largest talent pools in the world. We have more than 3 million software developers, data scientists, ML engineers, and other knowledge workers on our platform from 100 plus countries around the world. And these individuals are tested thoroughly over a range of skill-specific tests, programming tests, tests for communication skills, other kind of advanced capabilities as well, relating to whatever kind of work they can perform. And these individuals come from countries in Latin America, in Africa, in Eastern Europe, India, Vietnam, various other countries in Asia, and so on. And again, it is certainly key that we are able to pull into this global talent pool, and we have over time built a strong brand in a lot of these countries where the best and brightest from these countries wish to work with us full time, go through our extensive testing process and everything. That is certainly quite central to what we are able to do downstream. And yeah, today we work with the whole, as Mayur already mentioned, we work with a whole bunch of these foundation model companies. And there are, of course, companies like OpenAI, Google, Meta, and the others that are wishing to pursue AGI and that wish to make the models good across the board. But we also have clients like Snowflake, ServiceNow, and others that wish to make the models very good in some specific areas. For example, implementing their own proprietary language that makes it easier for clients to adopt them, things like that, basically. Yeah. And one or two more notes on this I would make is that the fact that, again, our talent pool comes from 100 plus countries around the world also means that there's a certain amount of independence and maybe lower correlations and everything between the kinds of ratings that different individuals produce. And obviously, in the machine learning world, all things equal, more diversity of data is better. The models just learn more, basically, compared to, say, all individuals being trained out of one office in one city, someplace in the world, who are all, come in with similar thoughts and ideas and training and everything. So yeah, so what we do at Turing is we collaborate with these large enterprises. We run these fully managed teams. And again, the fact that we have these large talent pools means we have been able to put together large teams of hundreds of individuals very, very rapidly in a matter of a couple of weeks and ensure have both tooling and processes to ensure good quality data and rapid model improvements. Okay. So now I'll talk more about best practices. This is just a little bit of background about Turing and why we are in this space at all. So today, right, at the highest level, when working with a typical client, what we would do is we'd first and foremost identify a backlog of areas for improvement. Sometimes some priorities come from the client. Sometimes the client would like us to engage in a certain amount of open-ended evaluations to identify gaps, areas of improvement that are congruent with their business goals, identify where specific models are behind the state-of-the-art models, all sorts of things. So ideas can come from different places. Then we then engage in a certain amount of continuous optimization, which I'll get to again in more detail, to improve models in parallel across a range of areas. Typically, there is a certain cycle of saturation after which we attempt to reallocate talent toward tasks that pull on more or less similar skills. So to improve models in a specific area, this is roughly speaking what the loop looks like. So the most important thing of all is first to be able to assemble a team that is skilled in the specific domain. Now this can be anything. It can be teaching the models to debug Python code. It can be helping the model fix issues in the code repository automatically. It can be teaching the model to be an AI data scientist that just works with high-level instructions, does an exploratory data analysis on your data set, gets initial data, knows how to ask intelligent follow-up questions, and does the same sort of a thing that maybe a data scientist might do over a month or so, and to generate business insights. So there's a lot of things. There's that. There's other areas as well which I'll get to. But the key thing here always is to try and make sure we are able to put together teams that are very competent at the task at hand. Because I mean, we all know this with machine learning or anything at all in software more. Generally, it's garbage in, garbage out, and putting together high-quality data sets is quite vital to create model improvements, and that is the first thing. Now, it is very common in a lot of these projects to, generally speaking, put together an evaluation data set first and foremost. It's very uncommon for any of our clients, these large foundation model companies, to just rely on a public benchmark and say, this is all I'll improve. And the reason is this thing, two or threefold, really. First, a lot of the public benchmarks are not considered very trustworthy because there's always a feeling that there are some kind of leakage issues. Like given the large amount of pre-trained data, the feeling is that the models might have seen the exact same question or the exact same concept or even something very similar, which means one is not really testing it on its ability to properly extrapolate. But there's very often clients are also looking to do something to improve the model in fairly fine-grained areas where no public benchmarks even exist. That also happens. So the common process after that is to, generally speaking, put together a supervised fine-tuning data set. Now, this is often done when the model is terrible in a certain area, and giving the model some kind of RLHF feedback is not even very valuable. Like, for example, let's say you were doing some task, right? Let's say you were submitting a paper to a conference and writing an abstract. Let's say, suppose you were fairly good at writing the abstract. You could ask your research advisor what version of the abstract looks better. Is it A or B? But this kind of feedback can only be useful if A and B are reasonably good. If both are terrible, you probably want examples on how to write an abstract in the first place. And that is more or less how it works here too, with both supervised fine-tuning and with RLHF. That loosely speaking, when the models are terrible in a specific area, there's a whole bunch of SFT work done. Once those there's enough data and the models have gotten pretty good at a specific area, RLHF can be a more efficient way to give feedback. So in supervised fine-tuning, one is putting together full examples, and I'll show you more. I think this can be a little bit abstract. In RLHF, you're often giving feedback on comparisons between two different model responses, or engaged in some kind of rewrites or other kinds of structured feedback, and so on. Yeah. The something, I mean, one has to have a good like process and tooling and everything, needless to say, to optimize quality and throughput. It is often desirable to have various kind of proxy metrics, to have a review process, to have some kind of performance reviews of individuals, etc. As well. Like, of course, the ultimate test that of whether a data set is useful at all is whether it improves the model. But one often wants cheaper ways to assess, and one wants ways to assess relatively smaller data sets as well. And the right kind of review processes, the right kind of measurement processes around these can be quite valuable. A lot of these end up being operationally quite operationally heavy activities to do well. Yeah. These are some of the best practices as we see it to ensure the high quality of these data sets. So I would divide these into two categories. One is ensuring high quality of the LLM data generators in the first place. The second one is, of course, conditioned on having a team of a certain quality. How do you make the most of that specific team? So in practice, we have seen that something like 70–75% of the levers just exist in the first bucket. Like if you were to put together a B or a C grade team and try to clean up after that team with an A+ process, that usually doesn't work well. You really need to get a strong team together, and even then, it's not clear that good quality data will come, but it is a necessary condition from what we've seen. So needless to say, the fact that we tap this global talent pool, we engage in rigorous vetting, we, roughly speaking, identify the top few % of the world's talent in specific areas is definitely a great starting point. But additionally, we also engage in performance reviews on the specific job. We have peer reviews, we have team lead reviews, and all sorts of structures in order to make this thing happen. Yeah, and additionally, of course, this is a complicated looking flowchart, but there's a lot of reviews of individual work that is done. There's performance reviews of individuals. There's with underperformers, there's a plan to attempt to coach them and try to turn around their performance, or manage them out ultimately if we feel there's no easy way to turn around performance. All these become key. Now, these are all some sample model areas that we help improve today. And this is, again, far from exhaustive, but this will hopefully sort of help you open up your mind to the set of possibilities that exist. So we do a lot of things around helping the models get better at coding and debugging, explaining code. Function and agent calling is quite quite an attractive area as well. Like, all of us ideally want the LLMs to behave like autonomous agents, do a lot of work end to end accurately, and so on. And very key to this thing is the ability to call proper APIs to use tools properly, and so on. And function calling is at the heart of a lot of that. Then, of course, I already mentioned data analysis. Then there's a lot of work we do around, and which is done around multimodality as well. Here, one may want to reason from videos, images, various other sorts of data. There are again various different variants here, and I'll get to some of them in the coming slides. There's also a lot of interest in, of course, this industry vertical stuff, right? Like trying to improve models on law, on medicine, various other sorts of things, depending on what a client is attempting to do. There's also a lot of stuff we do around this helping the models get better at PhD level physics, chemistry, mathematics, things like that, which again involves a completely different type of knowledge pool worker. There are also things we do around factuality, RAG labeling, and things like that, right? Like today, there's a desire again to be able to reduce LLM hallucinations as much as possible, to have their responses grounded in reality as firmly as possible, and so on. And those, again, can be appropriately trained. So here is a sort of a simple example of the way we might approach some of this open-ended evaluations that we might engage in for any of these companies building foundation models. where I don't think there's anything that's rocket science here. As you might expect, we try and cover the breadth of possibilities. We try and put together a taxonomy of different topics. We try and put together different prompt structures. We try to have do single turn prompts, multi-turn prompts, all sorts of things like that. We try to also vary the task difficulty and generate as comprehensive a report as possible in terms of what a model's capabilities are, where it is falling behind the state-of-the-art models, and one can also have a discussion with the client regarding their specific business goals itself and what is most vital. All right, now I'll get to some sample data sets, and often it is helpful to take a look at some of these to get a feel for how does one even create an evals data set or an SFT data set for many of these things. So here is an example of the kind of data set one might put together to enable improving coding. So one has this kind of conversation. It can again be a mix of a conversation, telling, getting the LLM to explain code to return some code in turn, etc. Have a conversation about whether you're using the right version of a specific library, all those things. This is what a function calling or a tool use kind of a data set looks like, where here what you're trying to do is given a large list of APIs, API definitions, documentation, which is some of which could be good, some of which may not be the best, just like what it is in the real world. Can you get the model to properly identify what function to call, how to call it with the right parameters, not hallucinate on any of these, and so on. This is an example of what the SFT datasets might look like for data analysis, where what you have on top there is the prompt, and this is the sort of expected response. Now, all this is generated end-to-end by humans. Yeah, here's an example of another kind of thing we do. Like there is quite a lot of interest in getting the LLMs to work well with some specialized expert knowledge, some under-resourced programming languages, and so on. So here are examples of this SFT examples for chip design. This is obviously of a lot of interest if you are a large chip design or a large GPU company. Then there are other sorts of tasks as well. Like obviously, there's a lot of work done by software engineers that involves various kinds of technology integration. Like for example, a company that, like for example, Amazon might be disproportionately interested in helping software developers integrate their technologies into various workflows and making that easier, for example. So this is an example of kind of a data set one might put together to try and get the model to be better at, say, high school mathematics capabilities. Here are the kind of data sets one might put together, again, for helping the model get better at other sorts of advanced STEM capabilities. This is what this is a simple example of what a factuality related data set might look like. Like ideally, you want to again identify a bunch of topics, get the model to respond, break the model response into a bunch of claims, mark them for accuracy, and so on. And this is an example of what RAG labeling might look like, because the way, when it comes to a lot of these responses, like one often wishes to improve your RAG system itself, and also improve your model's use of your underlying RAG system to ground its responses. And there again, having judgments regarding the relevance of a RAG source can be quite valuable. Yeah. This is an example of the maybe the one of the simplest forms of multimodal example training, right? Today, it turns out that a lot of these models even struggle on relatively simple tasks that involve some kind of business graphs and everything. In fact, this is a significant gap wherein a lot of this, the business graph information, if it were properly fed in the text format, it would probably work a lot better. The models may well be able to reason through it. So this is a lot of a low-hanging fruit for improvement, and unsurprisingly, there's a lot of work on that today. And here again, the idea is one puts together these data sets where you're trying to reason step by step and enable the model to engage in that kind of chain of thought reasoning, to walk through the business graph, what it is, what information is being read, and so on. There are also some variations here where portions of the SFT dataset are written in the form of code instead of in plain text format. Like, for example, over here, maybe you may first want to load a couple of arrays with the data in that particular chart, and then write 2 lines of Python code to actually engage in the relevant reasoning operation. And this idea of interleaving of teaching the model to write pieces of code and then execute the piece of code whenever possible is a powerful method to tighten up reasoning as a whole. Yeah, these are other examples of other kinds of multimodal tasks where you're trying to label videos, go a little bit beyond very basic sort of scene understanding and object detection and things like that to better understand what the models, what is happening in the scene. So this is what a typical, doing a typical RLHF task would look like. I don't know if it's easy for you to view, but typically there would be a, like, for example, I think this one says, please create a simple simple login web app. And here again, there are 2 model responses. There are pieces of code, etc. And the expectation from the from the human expert is to compare the 2 responses, to give various kinds of structured responses. If none of the 2 responses is very good, then take the better response and then rewrite it to and so on. There are also variations where we have some versions of process supervision where they are expected to fix the first line that went wrong, then let the model regenerate the rest of the responses, then go on to fix any errors there as well. Yeah, this is another example of the exact same kind. Okay, so I want to put some maybe suggested future research areas on the table that maybe are a bit more visible to us from the specific vantage point that we are in, which maybe don't come up as often. I'm not, there are of course a lot of exciting areas of work around synthetic data and other things in the research community that we are just like +1 for. I have not listed them here. So one thing I think that's of a lot of interest to us is I think this the structure of human versus LLM intelligence. So there's a lot of research in the area of psychometric testing around the nature of intelligence, around how different skills correlate with each other among humans and so on. And like one of the most powerful findings is the fact that a single principal component explains a giant amount of the variance, and it's difficult to find a number 2 component and so on. So it's definitely, I think it would be interesting to see if analogous concepts can be found with LLMs and how one might even go around putting it together, etc. I mean, LLMs, of course, are quite a different beast because they probably have 1,000 or 1,000,000 times the memory of humans, but a lower reasoning capability, which means tests that probe their reasoning capabilities have to necessarily look somewhat different than the tests that probe human capabilities. And another question is, of course, whether it leads to any insights regarding how to structure LLM post-training. Like today, some things have been found empirically. It has been kind of found that if you improve the model on coding, it does get better at reasoning as a whole. Something similar has been found when one does SFT or RLHF to improve mathematical capabilities. It does seem to have spillover effects. Now, it would certainly be interesting to subject those to some analysis and see whether if the correlation matrices look very different than what it looks for humans, and how that can inform what model areas you wish to attack in what order and so on. The another thing would be to toward the goal of maximizing incremental information gain per unit time of testing, right? So today, if you look at if you look at manual interviews versus automated interviews, right? Like automated interviews often tend to be quite sort of hyper structured. There could be a coding assignment where you get graded based on whether or not you pass the test cases and so on, whereas a lot of valuable information is certainly gleaned from human interviews, right? A human interviewer could give you partial credit for whether your approach is right. There are various system design kind of problems where it's an open-ended kind of collaborative exercise where there's a lot of signal that is gleaned. This sort of thing has definitely been difficult to test in the traditional interview formats, and I do think LLMs as interviewers could be quite valuable in this regard. Yeah, and specifically, like I do think both LLMs and humans have different comparative advantages, and a world where LLMs are able to judge humans, get the very best raters to produce human data for them, and humans in turn improve LLMs could be again very exciting given the very different comparative advantages. And then, needless to say, there's obviously a very interesting topic is how does one maximize ROI of the human data generation process? Like as I mentioned, a big part of the levers are certainly in terms of what kind of a team one is able to put together. But that said, there is still the question of what are the most optimal tasks to create that will most help the models while also being the kind that play to humans' strengths and the kind that humans can more naturally generate at high quality and throughput. What are the kinds of optimal review feedback processes and so on that will generate the steepest model improvement? Like today, a lot of these end up being very, very empirical. I want to say business-driven operations type of activities rather than really something that is guided by research in a big way. Then, yeah, there are certainly things with regard to how do you exploit sort of comparative advantages of humans and LLMs to even do these data generation tasks even more optimally. Could LLMs, is there again, this is done today with in a pure sort of empirical manner based on judgment and experience and things like that. But are there better ways to do this? Then today, again, even the question of using LLM as a judge, for example, for the human data process itself is moderately helpful in some domains, less helpful in some other domains. Again, a principled analysis of this could only help. What is the ideal way to use LLM as a judge here is all likely to be interesting also. And when it comes to RLHF, again, like a lot of papers are certainly about this, the version of RLHF where all one is doing is collecting binary preference data. But in practice in the industry, that is rarely how it is done. Often various other forms of structured data are collected. There's various kinds of rewrites and so on. And here, it would certainly be helpful to better understand how do you make most optimal use of the human's time to generate the maximum model improvements, right? Like for example, OpenAI did write this paper about a year back on process supervision, where they showed that labeling different steps in say a mathematical proof or some other kind of sequential reasoning process is a lot more helpful than just the outcome labeling. But the fact of the matter is that such a thing also takes more effort. And I think it would be an interesting question to know that given a fixed amount of human hours, how best to allocate it toward creating tasks of the right complexity. Like, do you do simpler tasks at more volume? Do you make the tasks more complex, in which case you can do less, etc.? Because these are all very, very pragmatic questions. Now, again, these are all done empirically, but I do think these might be interesting research questions. Yeah, thank you. That's all. Any questions? Yes, please.
Thank you for your response. So I'm just like very interested in your like basic business model of Turing. I'm just very curious about like how you price or value your data, or other words, like how to like income data, like how much they pay for.
Yeah. So often, again, I'm sure different companies do different things. We have not had much time or effort to get into the business of creating a data set once and selling it multiple times, etc. In which case, I think some of this it leads to more complicated questions on pricing and so on. In our case, virtually everything we do is bespoke, and to a first order approximation, virtually everything we do is something where we are directly billing based on something like person months or person hours. And that, of course, the cost of the individuals, of course, varies a great deal based on what you're talking. Are you talking labeling images for multimodal reasoning, or are you talking PhDs in physics? Yeah. Yes? I mean, okay, so first, that is the entire size of the pool that we pick from. It's not, it's not everyone from that pool that is active. But yeah, with regard to your specific question, I think we have been, I guess, a remote first company that's over time built a strong reputation for being a place where the best and brightest individuals from different countries can go on to have great careers and so on. So I think it's just been sort of embedded in our company DNA, and yeah, I think we have set the right best practices. We have, yeah, I think we have been at this for a while. They are either full-time employees or they are long-term full-time contractors. Yeah, yeah. Obviously, we operate in a lot of different countries. The laws vary by country. In some countries, engaging people as contractors is easier. In some countries, engaging them as employees is easier. Yeah, depends on the rules also. Yes. Yeah. So great question, right? Obviously, the final test of that everyone is interested in is whether the data helped improve the model or not. But of course, for that you need a relatively larger quantum of data. It's very difficult to get this thing get data point by data point feedback and so on. So there we have found that putting together good review processes, good raters, quickly identifying who the top performers are and so on is very central to the exercise. No, yeah. And again, when we work with a lot of these large companies, ideally they want all that taken care of them under the hood. Basically, researchers don't want to be in the business of ensuring that the individual human experts are all producing good data and so on. Yeah. So we actually maintain performance. We engage in performance reviews. We track different individuals' performance. We have various training and coaching boot camps. Some individuals that are highly underperforming maybe move to that boot camp first before they are brought back onto a project and so on. Yes. Yeah.
At the very beginning, you mentioned that a typical, I think, improvement for you is to generate 1,000 or 5,000 high-quality data points.
Early improvements that are measurable, yes.
And then later on, you said that it was about 30 to 120 minutes, all included for one data point.
Yes. That is.
If I scale that 5,000 times 120, that's about 10,000 hours of labor.
Yes.
To get it started. Is that?
Yes.
What is the cost of that? And is that, so the cost of the work that you're generating, is that something that only, big tech companies can support?
Yeah, I think yes. Yeah, I think that's a great question you bring up. Yes, you're right. The big tech companies are obviously investing tens of billions of dollars in this, and this sort of thing is pocket change, particularly if it generates such marked improvements in the models in different areas. So yes, as a general rule, we expect that a giant amount of this sort of investment is likely to come from the big tech companies. There is these other set of companies, the likes of a Salesforce, ServiceNow, SAP, and so on, that are likely to put maybe 1/10, 1/20th the investment by focusing on specific narrow areas. Like they may very well be willing to pull together a few tens of thousands of samples like this in the specific areas that they care about, which they feel the models are not going to naturally improve on, basically, because it's not a mainstream programming language or something else. If one is a very early stage startup, for example, frequently this does not, again, you never know. There are some startups these days that are able to raise 100 million on a deck. Those are of course different, but most early stage startups will likely want to find the lowest hanging fruit, engage in whatever small amount of fine tuning they want to on synthetic data, or maybe even just prompt and build a product end to end that serves whatever their end client use case is. Right. Ultimately, depending on one could be playing an applications game, one could be playing an infra game. There are a lot of companies that may do just fine zoning in on the client application and not building significant competitive advantages at this layer at all.
What we're saying is that right now LLM private model, open models, and there's sort of an arms race between all of these. There's a huge competitive advantage to owning a model that is very performant. And what you're sort of saying in this talk is that this bespoke kind of improvement of model is the best way of improving a model. So now what we're talking about...
I don't know about the best way. It is a very significant competitive advantage, and companies that don't do it are leaving a lot on the table, which is why I think everyone's come on board. Yeah.
How is this like, doesn't this entrench AI into personal interest as opposed to public interest? So for instance, can researchers afford to hire Turing for their public interest?
As a general rule, probably not, unless at a very small scale. I think in the context of some evals and so on, where the data sets are often smaller in size and scale, they can certainly engage Turing. But yes, are they likely to be able to engage Turing for SFT and actually improving a model to be the world's best in an area? Probably not. Yeah, it has certainly become that game of large capital investment, right? It's no different from can researchers afford similar GPUs as NVIDIA, as Google? Probably not. Yes, yeah.